Good afternoon, everybody. How was that lunch? Did everybody get a good lunch? I was like, tofu, yeah! If you're looking for tofu, you never get it, right? Till here. Thanks for coming. We have a session here until 3:10-ish, and then our next break. Matthew Groves is going to share some of our best practices, I guess, around moving from legacy to scalability. Matt's developer advocacy here at Couchbase, so you're getting it straight from the horse's mouth, and he'll go into his developer experience, and we can talk about all sorts of things, I'm sure, after this talk. So we have a 40-minute session where we'll do like 35 minutes and then some questions at the end. So you can invite questions in the middle if you want, Matthew, but after last session, I think maybe you should try to push them to the end, or we'll run over. So thank you very much, and it's all yours.
Thanks, Tyler. Can you guys hear me okay in the back? I'll take that as a yes. All right, excellent. So we've got a brief period of time to talk about migrations, and migrations is a huge topic, so yes, we'll wait till the end for questions there, if that's okay with you guys. I'm Matt Groves. I'm a developer advocate with Couchbase. My experience is mostly in the Microsoft world, .NET, SQL Server, and so on. I do a lot of blogging at blog.couchbase.com, so check that out. I've done a series on migration from SQL Server, so that's where my experience lies. But we'll have some content here if you're coming from Oracle or from any relational database, really. This is my agenda for today. We're going to spend some time talking about when should you consider migrating. When's the right time to switch from a legacy database to the scale of Couchbase? Most of the session will be talking about modeling. The most difficult part of migrating to NoSQL is coming up with the right model to store your data in. And actually moving the data is pretty simple once you start with a model to go from. And then accessing your data, the types of patterns you use to get your data out, whether you use the key value API, nickel query, full text search, that's going to inform the model of your data. And then we'll have some time at the end, hopefully, for Q&A. I'll be here all day if you guys want to talk after the session, too. OK, so picking the right application. This is key to figuring out how hard is it going to be for me to migrate? What are the challenges going to be? Now, you've seen this graphic, I'm sure, a bunch of times already about Couchbase. We're going to focus mainly on the core database engine and a little bit of the query part of that in red. And the rest of the stuff, you'll get plenty of detail on that later on. And you saw this during some of the keynotes today. But it's important to focus on where Couchbase is positioned within your enterprise, within your organization. Your transactional database, you may be shoving everything into that right now. It may be a complete silo. Everything goes into that database. And so when you want to pull something out from your transactional database, you may be pulling into one of those point solutions, one of those databases that are going to be your big database sprawl there. And so really, Couchbase is taking the place of those as your platform of choice to be your engagement database. This is sort of the eternal question. When you're used to relational, when do I use NoSQL? When do I use relational? It's really a question of, am I going to replace something, or am I going to complement something in my application already? So you can use Couchbase as your database of record, as your transactional database. We have some customers who do that. But you may also want to use it to complement your relational database, your system of record. But with NoSQL, with Couchbase, you can use it to add performance, add improved scalability, and availability for your relational databases. Most of our customers are, in fact, using both relational and NoSQL in some combination there. And we're seeing, Don Chamberlain kind of touched on this, we're seeing a very exciting time where NoSQL is adding relational features and vice versa. So it's a very exciting time. I'm very enthusiastic about the changes that are coming to databases. I don't have a crystal ball either, but I'm excited to see what's going to happen during that sort of convergence. So picking the right application. You can think of your application as something that your end user is interacting with, and it may itself interact with one or more services behind the scenes, and those services in turn act with databases behind them. And so if you want to increase your performance or add a caching service to your application, you can typically peel off a part of that application and use that, have NoSQL behind the scenes. And then the other parts of your application, we'll stick with your relational. As we saw in the keynote this morning, oftentimes customers are going to be interacting with those points of engagement thousands of times before they actually do one transaction that hits a relational database. So it's important for you to identify those pieces of your application where it's important for you to have good performance to provide to your customers. This is also a tricky subject, to think about the actual code that you're going to be updating and working with when you're doing a migration. If you have an application that follows some sort of SOA or microservice architecture, where your services are neatly defined and somewhat isolated already, it's going to be easier for you to slot in Couchbase there and replace that sliver of your application, that slice of your architecture, with NoSQL. If you're, on the other hand, your application, your architecture is kind of a spaghetti mess, and everything's all tangled together in one big monolith, for instance, it's going to be tough for you to pull out parts of that application to do that. So if you want to increase your chances of success, of adoption of NoSQL at your enterprise, it's best to focus on the applications that follow that architecture on the right and leave the spaghetti ones alone, because you'll end up having to do a complete rewrite of those, and that's just not going to be typically cost effective. So hopefully you have some applications in mind that you want to apply NoSQL to improve your performance, scalability, latency, and flexibility. So modeling your data is where we need to spend most of the time when you're actually doing the mechanical part of your migration. This is a handy table here, and these slides will be available to you afterwards for your reference. But when you think about relational, when you come from a relational world, those terms on the left, sometimes they're similar, but sometimes they're very different from the NoSQL world. So you can see kind of a loose translation here of what one thing means in the other's world. I want to focus on the table and row in relational. And as Don was just saying, there's not really tables in a NoSQL database. If you squint hard, you can kind of see JSON looks like tables. I like that quote a lot. But you can think of a document, the JSON document in Couchbase is something of a middle ground between a table and a row. So it is closer to a row because it represents one piece of data, but it also describes its own schema on a document by document level. As far as modeling approaches go, your traditional relational approach there has those characteristics on the right side. And there's really a spectrum here all the way over to the left with your NoSQL modeling. It's more of a relaxed model. Your normalization can still be there. You can still split up data if you want to, but you may also want to denormalize some of your data depending on your access patterns, and we'll talk about that some as we go forward here. But relational, it's rooted in the 70s where disk space was very, very expensive, and you were not trying to duplicate, you're trying not to duplicate data as much as possible. And it was useful back then, and it's still useful today for some applications. But for the most part, if we can group that data together into a document, we're going to see it's going to be easier for us to develop in an agile way, and it's going to be providing much better performance, much lower latency when we're pulling that data all out together as one piece. So hopefully you're familiar with JSON. You know what the benefits of JSON are. It's based on JavaScript. It's really just a means to an end. JSON provides the kind of structure that we need in a document database. It has hierarchies and arrays and the data types that are necessary to represent data. It's less verbose than other alternatives like XML and some other things like that. It's very human readable, and those are the kind of the reasons that we as web developers like JSON as a format. And it's also convenient for us that there's no impedance mismatch between a JSON document and a C# object or a Java object. Those can very easily map to each other, serialize and deserialize between them. We don't need an ORM tool like Entity Framework or Hibernate in a document database world. That sort of mapping, that mismatch does not exist. So I want to compare and contrast relational and document here. That's going to be the theme of the modeling exercise we're going through. You can see on the left, the relational database consists of both a schema and then the actual row of data, whereas a document database is just a single thing, describes its own schema and contains the data in one place. So this is where you can see on the left the difference between a table and row, and on the right you see a document that's a self-contained piece of data. Now with JSON, we get flexibility. Let me get the next slide here. There we go. So in this case, I'm showing two different documents that live together in the same database. And they don't have to have the exact same fields as one another. So you get some flexibility here. On the left, we have addresses, and we have a billing address and a shipping address. And on the right, we have the same thing, billing address and shipping address, but the shipping contains just a string instead of an object, because we don't want to have to duplicate. Oftentimes, you go to a form, and you have to type in the same information twice for billing and shipping. So in this case, we can just say, in our database, it's going to be the same. No reason to store it twice. It's just we're going to have it the same. Now, our application has to interpret this difference of data between the two documents. It has to say, well, in this case, shipping is an object. In this case, shipping is a string, and we'll process it differently. So some of the responsibility is being pushed to your application to manage that schema, to manage the document there. One tip, if you have different structures of documents as you go, as your agile development is changing the structure of the data as you go, it might be helpful for you to use a doc type field in your document to say, okay, this document is definitely of a user type, or this document is of an invoice type. And you may want to put a version on that and say, okay, we started out with version 1, the document looked like this. This document is now version 2, so you can have your application look at that value and handle the documents differently. There's nothing magical about those fields in Couchbase. You can call them doc type, you can call them type, underscore type, what have you. It's just a handy thing to put in your documents to keep track of what format your data is in. And this is the flexibility that you get with JSON, storing your data as in a NoSQL database. With relational, as we just demonstrated in the healthcare demo there, we made changes to the schema very quickly. We didn't have to arrange a committee and go through a week-long change request process to update our schema. All we basically did was update the data, update the UI, and we're done. Of course, it's not a magic bullet here. There is still a trade-off. There is no magical way that works all the time. So your relational database is going to enforce that schema. With the document database, your application needs to make those adjustments. So you gain flexibility, but you also gain more responsibility. With Couchbase, you can specify a key for each document, and you can specify that key however you want to. You can use a GUID or UUID or some sort of arbitrary random string in there, an incrementing integer. Those are all fine choices, but it might also be a good idea, and this is something we recommend that you try to do, is use something that's more of a natural key. Something that you can read and look at a glance and say, okay, I know that this document represents an author by the name of Shane. And you can use that key to form something of an ad hoc relationship between other documents and say, okay, I know that this blogs document must belong to the author of Shane. So we can go through these documents based on those semantic keys we've generated. We don't have to create an expensive query to do these. We can just walk through the structure based on those keys we've created. By the way, the smaller the key, the better. The more keys you can fit into the cache, the smaller they are. So that's a nice little tip from the field. Some of our customers have noticed that. As far as identity columns, I get asked about this a lot, is when I'm thinking about my database, I often create a primary key. It's an identity. It's incremented automatically by integers. Couchbase does not generate keys for you. You have to supply a key for the document. But if you still want to see incremented integers in your documents, you can use what's called the counter ability in Couchbase, the counter operation. You can create a document that keeps track of IDs and increment that document with the counter function. This is an example in Java, but it also works similarly in .NET or Node, et cetera. And get that ID. It's an atomic operation. When you're creating a new document, you can give it an ID of, say, author 101. The next one will be 102, et cetera. Or you may want to increment those by 10 in some cases to give yourself a little space between documents. Sometimes that might be helpful as well. As far as relationships go, It's not always the case you can put everything into a single document, so you still may want to break up your data. In this case, I'm showing a blog example here. I have an author, a blog, and a comment, and those relate to each other. And the way you want to model this really depends on your access patterns, but these are the two main approaches you can take. You can use the belongs to model, where you say comment, one or more comments belongs to a blog. So that comment contains a value that refers to a blog key. And the blog belongs to author. So there may be multiple blogs that belong to an author. And again, they refer to the author based on the author's document key. So it's sort of a bottom up. And then the reverse of that is the top down. You can say the author contains blogs. So the author document will have multiple keys, contain an array of keys to the blogs, and so on down to the comments. In a relational database, you typically use foreign keys to map very flat data to each other and map those relationships out. Now you can do something similar to that in a document database. So on the left or on the right here, you see the first example contains 3 documents. You have the user document with ID of user 100, and there are 2 billing addresses there. And you can see the first document, this is the has model we saw from the previous slide. It has the billing and the shipping keys that refer to the other documents, the user 100 address billing and user 100 address shipping. So it contains those references to the other documents. On the right model, we've denormalized it completely. So it's a single document that contains all the information, the user information, the shipping address, and the billing address. They're all in one place together. So when you're making modeling decisions, these are the 2 choices you have to pick between when you're referring documents to each other. Do I break it up into multiple documents, or do I nest it into one denormalized document? These are some rules of thumb that we've come up with at Couchbase to decide which one of those to use, which one of those is the best approach to modeling your data. And so I'm just not going to read all these to you, but you can see if on the left, then you probably want to look at the strategy on the right. Now, this is not a hard and fast, you should always do this. This is a good starting point for you to model your data. So for instance, if you have a one-to-one or one-to-many relationship between your data, it might be best for you to start with a nested model to see how that works. So a user has 1 or more addresses associated with their account. Start with them being nested. Right? But if you find out that most of your reads are going to be parent fields, then maybe you want to keep those addresses as separate documents because you're not going to be using those addresses all that much. So stick to the separating them into different documents. So a bunch of examples there. Again, those are just rules of thumb. So here's another example here. I've got the blog on the left. And it contains threads. And each thread points to a separate thread document. And then the thread document, I've also used the doc type here to set these documents apart. So I'm using both the key and a value within the document to indicate that this is a certain type of document. You may want to use one or both of these strategies in your database to say, okay, I can identify it by the key, and I can also identify it by the doc type in the document itself. So Couchbase does not enforce or validate any particular structure that I've just laid out here. This is really up to you and your application. So you have to think about these choices as you go forward. Do I use objects? Do I use arrays? What's my timestamp format? JSON famously does not have a date or a time data type. So you have to decide, am I going to use a Unix epoch integer, or am I going to use some sort of ISO string to determine how my date times are stored? I have to think about the difference between empty, null, and missing. Those are 3 distinct values that a document can have. It could have an empty string, which is different than a null value, and the field could just be missing entirely. Those are 3 different things that you have to think about. If you get a chance, stop by the Hackalade booth, one of our partners out there. They have a tool that can help you with modeling and creating modeling and collaborating on the different JSON models for your Couchbase database. And there's also a link here, and again, if you have the slides afterwards, you can click that link to see a presentation from last year about agile document modeling and data structures that was presented. It's a very relevant presentation as well. For modeling, accessing your data is a big part of making decisions about it. So we already saw the slide earlier, the rules of thumb about how you're accessing your data. But it's not just key value access that Couchbase has. We have all these different options of ways to get data out of your database. Nickel queries, which we talked about a lot already. Hopefully you've seen a lot of that or been to the workshops. MapReduce views are still a part of Couchbase, kind of one we emphasize less, but there's still some use cases where it might be useful. And full text search, which is just part of Couchbase 5, a great feature, and geospatial for location-based access. Nickel, I'm not going to go into it because we've spent a lot of time on Nickel at this conference, but you have the full capabilities that you have in your current relational database with SQL. You have those in Nickel as well. Joins, lots of functions, sorting, aggregation, it's all there. It might have a slightly different function name, might be a slightly different keyword, but you can do all the same stuff you can do in Oracle and SQL Server, you can do in Couchbase. Just a few Nickel examples. This one is using the related approach, where you have multiple documents. You have your users, and you have other documents that contain, say, payment information or accounts about a user. We can get information like, oh, I want to find all the users that have a Visa or MasterCard account. I need to use a join to do this, in this case, an intertwined, to bring those documents together in my query and perform some checks on those to see, okay, it's Visa or it's MasterCard. There's just some examples. So that's the related model that we're taking. And the other version is nested. The related data is nested amongst a single document. So we can do the same type of queries against that nested data, but now notice we don't have to rely on a join in this case. We're just querying a single document. We can get that data out of it. And we don't have to worry about transactions in this case either. If the data is nested, whenever you make changes to a document, that's an atomic operation. So there's less need for worry about different documents getting out of sync when you're doing transactions. Indexing is extremely important with Nickel as well. So you need to think about what are the queries I'm going to run, how am I going to index these fields. These are just a few examples of the indexes that offered by Couchbase, and we've added some more interesting options for querying with Nickel. Come by the Nickel booth later, and I can show you some of our adaptive indexes. And I can't remember the name for it, Tyler, but it's the indexes that you can replicate. Maybe it's just replicated indexes. GSI, yes. And memory optimized index is another one. Just tons of indexing options here, covering indexes, functional indexes, and so on. So a big part of figuring out the performance of your application is figuring out what is the right index for this type of query. It's even more important than relational. Oftentimes in relational, we have lots of tables. Maybe they're small tables. We can get away with, oh, I forgot to put an index on it, but it's only a small amount of data. With Couchbase, you have a huge amount of documents that are all together in one bucket, so indexing is extremely important for getting the right performance out of your data. Relational indexes are different than indexes in Couchbase, and that oftentimes indexes are synchronous, so they slow down your write operations as you write data to your database. With Couchbase, they are asynchronous, so it's not going to slow down your operations. The indexes will not affect your throughput there. And you can also use memory optimized indexes. So there's a trade-off here of I'm dedicating more RAM to my indexes, but I get better performance out of them with the new MOI feature of Couchbase there. Index load balancing is automatic, and it's based on the index signature, and that's something we've also improved a lot in Couchbase 5 to make that easier for you to develop and create those indexes that exist among multiple nodes in your cluster. To see your query plan, in previous releases of Couchbase 4, you could use the explain keyword. It may be hard to read up there on the screen, but you could put the word explain in front of your query, execute that, and you'll get this result of showing your query plan, your execution. What indexes is it hitting? What parts of the query plan make up this query when I execute it? And that is a great way to see and make sure that I'm hitting the correct indexes, the index that I expected to hit. In Couchbase 5, we introduced the visual query plan. So I'm more of a visual person myself. I like this feature a lot. I can execute a query and see exactly which parts of that query are taking up most of the time that's executing to the query. So I can focus on that. And I can also see, in this case, 2 index scans are being run as part of this query. So that's good. I'm hitting the index that I expect to. And I can see that, oh, fetch, the bottom part of the fetch is taking the most time, so maybe I can focus on that part of the query. Or the distinct is taking a lot of time, so I can maybe figure out a way to write the query and to better perform. So just to sum up here, we talked about key value. Those provide the best possible performance, by the way. So if you know the key to your document, use a key value operation to get or set that document. That's always going to be the fastest. MapReduce views are still out there. They are well suited to certain types of aggregation, but they are limited in their flexibility, and you have to really create them ahead of time. So Nickel provides the most flexibility for everything else you need to do in your application. So if you don't know the key to your documents, you want to query by some other attribute, use Nickel to do that. It can work on both the nested and the related models of your JSON documents. Okay, and then once you've got the model, that's really the hardest part of this. And then moving the data over, I recommend keeping a very simple approach to start with. Identify your requirements. Are you going to do a straight ETL? Are you going to take the time to clean up your data a little bit? Some of that data that's been sitting around, festering and looking kind of ugly from 10 years ago, some test data in there. Take the time now to clean that up when you're doing the move over. Or maybe enrich the data, add some more fields to it, pulling in from other sources. You have to think a lot about the duration of your migration. Is this going to be something that you're going to execute over a period of months? Or is this going to be a one-shot that happens in one weekend? And what are your resources for that? Do you have budget for tooling? Do you have budget for your developers' time to work on this ETL, to work on the migration? And governance is very important. And this is beyond a technical issue now, is who's in charge of this data? Where does this data come from? Do I need to keep track of it when I move it over to this new data source? And do I have the right permission to do that? What are the legal requirements for that if you're in the healthcare industry of storing that data? Your strategy, you need to think about terms of time versus performance and resources. There's sort of an iron triangle there. Again, do I do a big batch of them at once, or do I do one record at a time? How's that going to affect my operations or my current customers? Single thread is going to be easier, but it's not going to necessarily be the best use of resources, computing resources. Multi-threaded is going to maybe be faster, take more advantage of the resources, but it's more complex to manage that. What sort of tools do you have available to you? Do you have access to migration tools like Informatica, Looker, or Talend? These are all tools that can work with Couchbase. Do you want to bring your own tool or build your own tool, maybe with a Python script, or use a Spark connector with Couchbase or Kafka? Another interesting possibility is what's called SQSL. That's not a typo up there. It's the structured query scripting language, which can actually interact with just about every relational database that you've heard of, as well as Couchbase. So you can script the migration of data from one place to another. I'm going to give you a link here in a few slides to a lengthy tutorial on how to use SQSL to migrate your data to Couchbase. But I recommend, again, you start simply. Start with the simplest thing you can do and see how it goes from there. You can export your data from a relational database to CSV, and then you can import that to like a staging bucket in Couchbase, just a straight import from CSV to Couchbase. And then in that staging bucket, you can use Nickel to manipulate and transform that data in place. And then when you're done, you can then put into a new operational bucket. Or you might take another approach and do your transformation in your current database with using the SQL tools you have available there, and then export that into a CSV and then eventually into Couchbase. So you can do the transformation before or after you do the export there. ETL versus an ELT, for instance. But the key here is that you have that data model ahead of time that you can align your data with. So you know that when I export these 3 tables, they're going to end up as 3 documents or 1 nested document when I'm done with them. It's also important to plan for failure. This is something I've learned a lot in my experience doing a lot of relational migration in the past, is that you may start with a small set of sample data, everything works great, and then when you go and run it against the full database, oh, now I have an out-of-memory error, or there's a piece of data that wasn't formatted like I expect, some of that old test data perhaps that's still hanging around somehow, or a resource limitation might happen. again, I run out of memory, out of memory exception. I didn't plan correctly. I put too much into memory at a time. So if you plan that you're going to fail, then you can make sure that the code you're writing, the ETLs you're writing, the migration that you're writing, can be interrupted. You can stop it when you know something's going wrong and say, okay, I don't want to let this 8-hour process play out. I'm just going to stop it right here. And then make sure you can restart it if you need to, as many times as you need to restart that operation. And you're logging every step of the way, so you know exactly when it fails, okay, it was this piece of data that caused it to fail, or this transformation that didn't go how we expected to. And when you do all these things, your migration can be very predictable and become very boring, which is what we like when we're doing migrations. Nice and boring. As far as specific tools, for syncing, now sometimes when you're doing a migration, you might want to do a period of syncing where it's a transitional period. You want to have relational and Couchbase at the same time. Or ultimately, if you're running them together in the same application, you may want to sync from one to the other in a continuous fashion, just in perpetuity. You want to sync that data with each other. So from going from Couchbase to relational, one of the tools you can use is Kafka, which is a streaming tool you can use. It's connected to Couchbase via the DCP protocol. It's a connector that we've built that we support, you can use, and a relational database can consume from Kafka. The other way around, you can use tools like Golden Gate to connect to your Oracle database, or SQL Server as SSIS, which is a tool you use to transfer data from SQL Server to other places. And there's an open source Golden Gate connector for Couchbase. There's a link to it there on GitHub. There's a third-party provider for SSIS provided by CData you can use to connect from relational to Couchbase. And then some more tips from the field. So I was talking recently to some of our engineers, and I asked them what sort of tips they had, some practical tips they had for migrating data and some of the stuff they've seen in the field. And one of the things they mentioned was that you might want to consider adding your indexes after you migrate the data over to reduce the total impact of those indexes on your migration. Now, indexing does not affect the throughput because we already established it's asynchronous, but it still does take resources to do that. It might be good to wait until the end to run those indexes. Use SQSL. So there's a link to the blog post there. You might want to take a picture of that because it's kind of hard to remember. But it's a very long post on how to use the SQL Server or SQL query scripting language, which is a tool you may not be familiar with, but it's a really handy tool for scripting out these types of migrations. And finally, if you are at the point where you have JSON, not CSV, but you want to import JSON data, make sure that it's valid JSON. You might run into some problems, some errors when you try to import JSON data that is technically not valid JSON. It may have line endings in it. It may have smart quotes, things like that. You may want to run it through a JSON linter to make sure that there's not any characters in there that you weren't expecting. Okay, so here's a quick recap. All the stuff I've covered here. Pick the right application. Make sure you have a data model in advance of doing your migration. Match your methods to the requirements. So is nickel the right thing? Is a key value the right thing? Is a map reduce the right thing? And create a proof of concept. This is something we can help you with at Couchbase. We would love to help you create a proof of concept for the application you're thinking about moving to NoSQL for those benefits. We want you to be successful, so please let us help you with a proof of concept. Okay. Questions? We have about 5 minutes for questions, so Tyler here has a microphone.
We got a few more minutes than I wanted you to finish in 5, so then we have 5 for questions. It's okay.
I got more resources too, so we got time.
If there's questions, just please raise your hand. It's hard to hear in this room, so I'll pass around the mic.
Thank you for the session. This was probably the most useful for me, coming from a solution that has a MySQL, and we're trying to get to something that's a little bit more scalable. I just have a question on the last thing you just said, that you can help us. How do we contact you? How do we reach you? What's that engagement model?
Very good question. So you can contact me. I have my cards up here, and also some stickers, by the way. Please come take some stickers. Anybody you see in a blue shirt, they'll be able to help you find somebody to contact. We can get someone from the Solution Engineers team or from the Center of Excellence to come out and just even do a lunch and learn with you, or help you build a proof of concept application early on. We would love to help you do that.
We also have a dedicated training team that does on-site training and online training. And I'm not sure if there's a data modeling training course specifically online.
Yes, there is a data modeling training course.
And there's developers courses as well. So
here's a link to the training right here, training.couchbase.com.
Does that answer? Is that enough resources? Any other question? Dig deep. Can you get the deck?
Yes.
All attendees will get a follow-up email with the videos that were streamed and the slideshow that you can download. Dig your deepest, darkest data modeling questions out here. There's got to be more transformation questions and stuff. Has anyone gone through a migration similar to what's been discussed today and want to share their success or failure? No one wants to confess to failure. Yeah, you'll be given access to the map emailed out after. Yeah. Wow, seriously, there's no rush. So, okay, I'll go over the agenda. Thank you very much, Matt. Let's give him a
Thank you.
Thanks. So the agenda that you probably have already seen already, we have a break, a half an hour break from 3:15 to 3:45. We continue here for the rest of the afternoon with 3 specific customers of ours and that are going to go into really large-scale deployment examples for you. So John from PayPal, we have eBay, and we have Amazon talking as well this afternoon. So I hope you'll come back and enjoy those sessions as well, but give you a chance to go and get caffeinated for a bit, do some networking. We have little kiosks around, and if you just want to hear the latest, greatest things from Couchbase employees directly, just come and ask your questions. Thanks for coming out, and thanks for your participation. We start back here at 3:45.